Hey, champs of Examsnet. Welcome to the question series of Examsnet. Today we'll be solving Telangana EAMCET 18 July 2022 Shift 2 paper. This paper, we'll be solving the mathematics portion of the paper, which is having about 80 questions. You are aware of that. So I hope you're well prepared for this exam. Very best of luck. We'll start with the paper shortly. Before that, here's a recommendation. Do visit our website, www.examsnet.com. There you will find not only this, but similar type of multiple entrance exam question paper with their detailed explanation, which will be very helpful to you for your exams preparation. You can also download our app. The link is available in the description box. So let's start with the paper. Here we go. First sum, best of luck. Question number 1. Okay, it's a sets problem. It says, let C be the set of all real numbers such that statement 1 says the function f is defined from minus pi by 2 to c, where c says it's a set of all real numbers. It is defined by fx is given to be this function, and this is one-to-one function. Hope you know what is a one-to-one function, right? I don't think I need to tell you. So one-to-one functions are something like this. Next one, the function f from 0 to infinity, 0 infinity, these are from this thing, from this set to c, which is a set of all real numbers, is defined by fx is equal to x square. This is also a one-to-one function. So you have to tell whether the statement 1 is true. What about like statement 1 and 2? Which one is true? So f is a function from minus pi by 2 to pi by 2 to the real numbers. Actually, the c was given to be the set of real numbers. So the real numbers. Now, fx in this case is given to be secant x plus tangent of x. You know, the secant x is given by, you can write down secant x as 1 plus tan square x by 2, 1 minus tan square x by 2 plus 2 tan x by 2, 1 minus tan square x by 2. So taking the LCM, you can write down 1 minus tan square x by 2. In the numerator, it will be 1 plus tan square x by 2 plus 2 tan x by 2. This is equal to like a plus b whole square formula, identity. You can write down this as 1 plus tan x by 2 whole square upon. Now I can split it up. 1 minus tan square x can be written as 1 plus tan square x, tan x by 2, and 1 minus tan x by 2. So this and this will get cancelled. You will be left with 1 plus tan x by 2, 1 minus tangent of x by 2. Right. 1 can be, see, 1 is equal to tan pi by 4. Therefore, I can write down this. This is the formula for tan pi by 4 plus x by 2. Right. Now, if I find out the derivative of it, the first derivative, the function f dash x, the derivative will come out to be secant square this into coefficient of x, which is equal to 1 by 2, right? Of course, this is greater than 0. Why? Because for all x belonging to this interval, you know, this will give you a positive value for sure. Now here, that means this is a positive value, which means that fx is an increasing function. Correct? Next, okay, therefore it's an increasing function, which also means one more thing, that this is one-to-one function. Okay. Now, second one, the second statement says that f is a function and the is the domain 0 to infinity. From this to the real numbers, fx is given to be x square. Simple as it. So first derivative will be equal to 2x. This is greater than equal to 0 for all x which belong to 0 to infinity, because there is no negative number over here. Therefore, this is also increasing function. That means it's a one-to-one function. Therefore, fx is increasing, which simply means this is a one-to-one function. So that means both the statements are true. 1 and 2 are true. This is one-to-one function, and even this one is a one-to-one function, which is given in the statements that they are both one-to-one functions, which means that we have both statements as true. Option C stands to be the correct answer. Hope you understood this. Next is question number 2. Now let's see with the set of all real numbers. Let f is such that f is a function from real numbers to real numbers, be the function which is defined by these criteria. Okay, this is equal to 2x minus 5 if x is less than minus 3, x plus 2 if x has a range from minus 3 to 5, and if x is greater than equal to 5, fx is given by 3x plus 1. You have to match them. Okay. All right, so I'll pick up the first one, the first A part. It's f of minus 5 plus f of 0 plus f of minus 1. This is equal to. Now for f of minus 5, this is less than 3. So I'll pick up this function for this thing. 2 into minus 5 plus f of 0. So this will lie between the second one, second one, x plus 2. So this will be 0 plus 2 plus f of minus 1. F of minus 1 will give you 3. Okay, I'll go with this. 3 into minus 1 plus 1. So you will have this is minus 15, right? And plus 2. Give me a minute. Sorry, f is greater than, this is not the function to be taken over here. So f is minus 1, which will lie between like 0 to, x plus 2. So this will be minus 1 plus 2. And here I will have plus 1, which will give me minus 12. Okay, so that means this matches, A matches with this option. Got that? Let's go with the B option. So B1 says f function of 5 plus 10 f of minus 3. Okay, so this can be written as, since it is 5, so this will be function of 3 into 5 plus 1 plus 10 into minus 3 plus 2, which will be function of 15 and 16 plus this is minus 10, that is function of 6. Now this is greater than 5. So I'll take 3x plus 1 now. So this is equal to 3 into 6 plus 1, which is equal to 19. So this matches with last one, 19. Let's go with the C part. It says function of modulus of function of minus 4. Okay, so this will be written as function of modulus of minus 4. Okay, I'll pick up for x is less than this, a 2x minus 5 function. So this will be modulus of 2x minus 5. So this will be 8 minus 8 minus 5, which is minus 13. So this is equal to minus 13, right? Now the function of minus 13 will be given by, this is 3 into 13 plus 1. Since a mod function, so negative sign will go away and you will have 40 for this. So this matches with this. D option, f of 1. So 1, for 1, I have x plus 2 function. So this will be function of 1 plus 2, which is 3. Now 3 will come in the same x plus 2 function. So I'll have f of 3 plus 2, which is 5. Now 5 is greater than equal to 5. Now I'll take 3x plus 1 function, this function. So this is equal to 3 x plus 1, which is equal to 16. So let's check this matches, last one matches with 16. So what is the correct answer? Which one is the correct option? A matches with, if I'm naming this as 1, 2, 3, 4, and 5. Okay, A matches with 4, and B matches with 5, C matches with 2, and D matches with 1. So this is option C. Hope you got that, right? Let's move to the next question, number 3. This is a matrix problem before us. You are given A plus B is equal to this. A multiply B is this matrix. Then A square plus B into A plus B is equal to what? All right. So you are given the matrices. Let's write down them first. This is A plus B and this is A into B. You know one thing, A plus B whole square. This is equal to 2, 1, 2, 1, 2, 0, 0, 2, 2, 2, 1, 2, 1, 2, 0, 0, 2, 2. Okay. So, all right, let's do the multiplication now. So, you know this thing, this will be first row, first column. This will be 4 plus 1, that is 5. Then is 2 plus 2 plus 2. 4, sorry, this is 8. Now this is 4 plus 0 plus 4. This is equal to 8 again. Similarly, you will solve the whole thing. I hope you know the multiplication problem, like how you are going to do this. It's first row into first column, then first row into second column, then first row into third column. Similarly, second row, first column, second row, second column, second row, third column, and so on. Okay. So solving this, you will get 5, 8, 8, 4, 5, 2, and 2, 8, 4. This will be the final matrix A plus B whole square. Okay. So A plus B square, you know one thing, this is equal to A square plus B square plus AB plus BA in the case of matrices, right? So that means A square plus B square plus BA is equal to A plus B whole square minus AB. Or you can take B common from here. So A square plus B and A plus B, this is equal to. Now, A plus B whole square, we just calculated this one, 588. Let's write it down. 5, 8, 8, 4, 5, 2, 2, 8, 4. Minus AB. AB matrix was given to you as 1, 2, 2, 1, 1, 0, 1, 2, 1. Okay. So, if you go for the solution, you will get 4, 6, 6, 3, 4, 2, 1, 6, 3. This is the answer to the question. Let's check with the options now. 4, 6, 6, 3, 4, 2, 1, 6, 3. This is option A. So this is the correct answer to our problem. Hope you understood this one. Next, question number 4. All right, again a matrix problem. It says A, P, B are 3 by 3 matrices. If mod of minus B, modulus of this is 5, and this BA transpose is mod of that, determinant of that, sorry, is 15, and determinant of this matrix is equal to minus 27. Then one of the values of determinant of P is what? You are given that determinant of minus of B matrix, this is equal to 5. So you can also write down this as minus 1 is to power 3. Determinant of B is equal to 5, right? Or determinant of B is equal to 5. Simply say the determinant of B, this is equal to minus 5. Second thing you are given that determinant of B into A matrix transpose is equal to 15. You can also write down this as B matrix determinant into A matrix determinant, transpose of A matrix determinant is this. And B was equal to minus 5. So minus 5 into this is equal to this. So determinant of A matrix transpose is equal to minus 3. Okay. One thing more, A matrix transpose, you know one thing, this determinant is actually equal to this. So I can write down this also over here. Minus A determinant is equal to minus 3. Now let's go with the last one. You had, third thing that you had was determinant of P T A P is equal to minus 27. This can be written as P matrix transpose into A matrix determinant. Determinant of this matrix into determinant of this matrix into determinant of P is equal to this. This is equal to P A P minus 27. A was equal to minus 3. So P matrix determinant square is equal to 9, which gives you this is equal to plus minus 3. Okay, so we have two values for the determinant of P, that is plus minus 3. We don't have the minus 3 as an option, so plus 3 is the available option. Hence, option A stands to be the correct answer. Hope you understood this. Next is question number 5. If A is a 3 by 3 matrix and determinant of A is half, then determinant of A inverse adjoint of A inverse whole inverse is equal to what? So we'll move step by step. We have determinant of A is equal to half. We have to find out this thing. Let's write it down. So A inverse, determinant of A inverse into adjoint of A whole inverse. This can be written as 1 upon A inverse adjoint A. This is equal to 1 upon this into adjoint of A. This is further equal to 1 upon this into, now adjoint of A, this can be written as adjoint A raised to power 3 minus 1. Now, question number 5, if A is a 3 by 3 matrix and determinant of A is half, then you have to find out this whole thing. Okay, let's start with the question. So you are given that determinant of A is 1 by 2 and you have to find out A inverse determinant of into adjoint of A inverse. Okay. All right. So this can be written as actually 1 upon, because this whole was, I think this whole is inverse, the outside, it's outside. So this can be written as determinant of A inverse into determinant of adjoint of A, right? Okay, I think this is the one. Yes, right. So now this can be further written as this will be 1 upon determinant of A inverse into adjoint of A determinant. There's a formula for this, right? If give me a minute. Straight line. So if this is a n by n matrix, then the formula for this is given by adjoint of determinant of A raised to power n square minus 2n plus 1. Okay. So now I'll fill in the formula for this. Here it's a 3 by 3 matrix. So this will be written as determinant of A raised to power 3 square minus 2 into 3 plus 1. So this will be equal to 1 upon determinant of A raised to power 9 minus 6, that is 3 plus 1, that is equal to 4. So this will be equal to 1 upon determinant of A 4 minus 1, that is raised to power 3. You know determinant of A, that is equal to 1 by 2. So this, which will be equal to 1 upon 8, that is equal to 8. So you have the answer to the question as option A, 8. Hope you got that. Next is question number 6. Again, a matrix problem. It says let X is equal to alpha, Y is equal to beta, Z is equal to gamma be the unique solution of the system of simultaneous linear equations. These are the simultaneous linear equations in 3 variables, 1, 2, and 3. If alpha is equal to minus 2, then you have to find out the value of beta. All right. So these are the 3 equations. Let's write them down first. 2x plus 3y minus 2z is equal to minus 4. Second one is 3x minus 4y plus 3z is equal to minus 5. The last one, kx minus 2y plus z is equal to minus 3. Let's find out the determinant for the matrices. For this matrix, it will be 2, 3 minus 2, 3 minus 4, 3, k minus 2 and 1. Let's find out the determinant. So you will have 2 into minus 4 plus 6 minus 3 into 3 minus 3k minus 4 into minus 6 plus 4k. This will be 2, 4 minus 3 into this will be minus 9 plus 9k plus 24 minus 16k. So this is 28. Okay, fine. This will come out to be give me a minute. Actually, here's a slight mistake. It was supposed to be minus 2 and I by mistake wrote minus 4 over here. So it will be 2 and this will be 12 and this has got to be 8. Okay, I'll write it again. This is 4 minus 9 plus 9k plus 12 minus 8k. Okay, yeah. So now this is equal to k plus 7. The determinant comes out to be k plus 7. Next. Okay. So next is dx can be written as determinant of minus 4, 3, minus 2, minus 5, minus 4, 3, minus 3, minus 2, and 1. Okay. So let's find out a determinant in this case also. This will be minus 4 into minus 4 plus 6, which will be 2. Minus 3 into minus 5 plus 6, which will be 1. Plus 9, sorry. Minus 5 plus 9, which is equal to 4. Minus 2 into minus 10, minus 12, minus 10 into... give me a minute. Sorry, 10. And this will be minus 2. Okay. So this comes out to be, you will solve this. This comes out to be minus 16. Now, alpha is equal to this, which is equal to minus 2. It's given in the question. That means minus 16 upon k plus 7 is equal to minus 2, which gives you minus, this will cancel out and you will have 8. So 8 is equal to k plus 7, which gives you k is equal to 1. Okay. So this is what you were looking for. Okay, this is the matrix. So for k is equal to 1, you can write it as... Actually, we will have to check each and every option. For the option 1, the determinant will be equal to 5 minus 6, which is minus 1. So this is the incorrect one. Next is 10 minus 3, which is 7. Wrong. Next is 6 minus 5, which is 1. That means this is the correct one. Next is 3 minus 10, which is equal to minus 7. So this is also incorrect. So this clearly shows that option C is the one which is satisfying k is equal to 1. Hope you understood this. Let's understand this whole problem once again. You were given that x is equal to alpha, y is equal to beta, z is equal to gamma. These are the unique solution for the system of linear equations. These 3 equations are given to you when alpha is equal to minus 2. And what is alpha? This is given by determinant of x upon d. Okay. First of all, we solved it for d and then we solved for dx. Then definitely we found out the determinants of the two cases. Alpha was equal to dx upon d, which was equal to minus 2. It is given in the question. So solving this, we got the value of k as 1. But k as 1, k is equal to 1 is not given in the options. So I checked out each and every option once to see which option is giving you the determinant as 1. And option C was the only one to give me the determinant as 1. Therefore, this is the answer. Hope you understood this. Let's move to the next question. question number 7, if the point x, y satisfies this equation, then x plus y is equal to what? So basically you have to find out x and y and then you have to add it, right? Let's write it down. The equation will be, I'm starting from here as it is. So the equation will be x plus x minus 2 iota upon 3 plus iota minus 2y plus 1 minus 3y iota upon I minus 3 iota is equal to iota. So this will give you, let's take the LCM. This is I plus 3 into I minus 3. This will simply be equal to I square minus 3 square. And let's take the LCM now. LCM have been taken. Let's multiply it with the numerator. So you will have x into iota minus 3 plus iota minus 3 into x iota minus 2 iota minus 2y 3 plus iota plus 3 minus iota plus 3 iota minus 3y iota is equal to iota. So let's solve this. You will have this will be x iota minus 3x plus x iota square minus 2 iota square minus 3x iota plus 6 iota minus 2y iota minus 6y minus iota square, then minus 3y iota square plus 3 iota minus 9y iota. Whole is divided by iota square. This is equal to minus 1 square minus 1 and this is equal to minus 9. Now this was whole equal to iota, right? Okay, now this is x iota and minus 3x iota, then 6 iota, 2y iota and minus 3 iota plus 10y iota minus 3x and this can be written as minus x. This will be plus 2 and this will be minus 6y. Minus of minus 1 will give you plus 1 and this will be minus 3y. I think we are done with everything, right? This is equal to minus 10 iota because this minus 10 will go on the right hand side and it will get multiplied. Okay. Now, this will be minus 2x iota plus 3 iota plus 8y iota minus 4x plus 3 minus 9y is equal to minus 10 iota. So let's separate the real and the imaginary parts now. So this will be minus 4x plus 3 minus 9y plus minus 2x iota. Iota I will not write now. Okay, minus 2x plus 3 plus 8y. I'll write iota here is equal to minus 10 iota. Multiplying both sides by minus, you will get 4x minus 3 plus 9y plus 2x minus 3 Here's a small mistake. Actually, this was 9y iota and I wrote 10. Okay, so this comes out to be 7. All right, so this is 2x minus 3 minus 7y because Question number 7. Now we have a complex number problem with us. It says if the point xy satisfies this particular equation of the complex numbers, then x plus y is equal to what? So basically in the question, you have to find out x and y and then you have to add them. Okay, we can do that easily using the complex numbers. Let's go for this. I'll start from here itself. Now this can be written as x plus x iota minus 2 iota. I have opened up the numerator, divided by 1 plus 3 iota. Now I will take this on the left hand side. So minus 2y, give me a minute, minus 2y plus iota minus 3y iota upon iota minus 3. This is equal to iota. I'll take the iota on the right hand side. Now take the LCM. This will be iota plus 3 into iota minus 3, which can be written as iota square minus 3 square. So x plus x iota minus 2 iota multiply iota minus 3 minus 2y plus iota minus 3y iota into iota plus 3 is equal to iota. Let's open up the brackets. Now you have to do it very patiently because very long numbers will be there, iota squares will be there. So it's not a tough question, but the mistakes probability is quite high over here. Okay, so x iota minus 3x plus x iota square minus 3x iota minus 2 iota square plus 6 iota minus, I'll keep it in brackets, 2y iota 6y plus iota square plus 3 iota minus 3y iota square minus 9y iota. This is equal to iota and this whole is divided by minus 1 minus 9. I hope you know this thing that iota square is equal to minus 1. So let's open it up. I'll segregate the iota terms and the non-iota terms now. So this will be x iota minus 3x iota plus 6 iota minus 2y iota minus 3 iota plus 9y iota. These are the imaginary terms minus 3x. Now x iota square, this is equal to minus x and this will be plus 2. This thing will be minus iota square is equal to minus 1. So minus 2 into minus 1 will give you plus 2. Next, minus 6y iota square is equal to minus 1. So minus this will be plus 1. And this is equal to, this term is equal to plus 3y, which on opening will give you minus 3y. And I think we are done with all the terms, right? So this is equal to minus 10 iota. Okay, so this can be written as minus 2x plus 7y and plus 3 iota. Okay, minus, this will be minus 4x plus 3 minus 9y. This is equal to minus 10 iota. Now let's multiply both the sides with minus. You will get 4x minus 3 plus 9y plus 2x minus 7y minus 3 iota is equal to 0 plus 10 iota. Right? Hope this is clear. Now let's do the comparison of the negative sides. Like this is the real part, this is equal to 0. And this is the imaginary part and this is equal to 10. We have two equations now. That is 4x minus 3 plus 9y is equal to 0. Also 2x minus 7y minus 3 is equal to 10. These are the two equations I am having. So this can be written as 4x plus 9y is equal to 3 and 2x minus 7y is equal to 13. Now let's multiply the equation 2 with 2 and then subtracting them. You will have 4x plus 9y is equal to 3. 4x minus 14y is equal to 26. Minus plus minus. They will cancel out and you will have 25 is equal to 25y is equal to, sorry, 23y is equal to minus 23, which gives you y is equal to minus 1. And from there, you can calculate y. X also, I had the equation 4x plus 9y is equal to 3. 4x minus 9 is equal to 3, or x will come out to be 3. So 12 divided by 4 gives you 3. And you have to add both of them. You have to find out x plus y, which is equal to 3 plus minus 1. That is equal to 2. So the value of the answer is equal to 2. Option B is the correct answer. Hope you got that. Next is question number 8. Trigonometry problem before us. If cos alpha plus cos beta plus cos gamma is equal to 0, sin alpha plus beta plus gamma is equal to 0, then cos 2 alpha plus 2 beta plus 2 gamma is equal to what? Okay, so you are given that over here, you can write down, I will write down this in the terms of complex number. First complex number can be written as e raised to power iota alpha. And Z2 can be written as e raised to power question number 8. It says if cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0, then you have to find out the value of cos 2 alpha, cos 2 beta plus cos 2 gamma. In this question, first of all, I'll assume that A be any complex number of the type cos alpha plus iota sin alpha. B be cos beta iota sin beta, and CB cos gamma plus iota sin gamma. This can be written as e raised to power iota alpha, e raised to power iota beta, and iota gamma. Right? Now, let's add both all the three. Let's do A plus B plus C. So after adding them, you will have cos alpha, cos beta, cos gamma plus sin alpha, sin beta, sin gamma, sin alpha, sin beta, and sin gamma iota. Right, now this was equal to 0. In the question it's given plus 0 iota. So that means simply A plus B plus C is equal to 0. Let's name this thing as 1. Also, let's do 1 upon A upon 1 upon A plus 1 upon B plus 1 upon C. This is equal to A raised to power minus iota alpha, E raised to power minus iota beta, E raised to power minus iota gamma. So this is when I'll put alpha as minus 1. So this can be written as cos minus alpha minus beta and minus gamma. Plus sin minus alpha, sin minus beta, sin minus gamma iota. Now cos alpha is equal to alpha, cos alpha only. Cos minus alpha is equal to cos alpha only. This is cos beta and cos gamma. But sin minus alpha will be equal to minus sin alpha, minus beta will be equal to minus sin beta, and sin gamma will be equal to minus sin gamma. I'll take the minus outside as common, and this will be sin alpha, sin beta, and sin gamma iota. This was equal to 0 minus 0 iota, which is equal to 0. So that means 1 upon A plus 1 upon B plus 1 upon C is also equal to 0. Let's name this as number 2 equation. Now we have from 1, A plus B plus C was equal to 0. Let's do squaring on both the sides. So you will have A square plus B square AB, BC, and CA. This is equal to 0. This can be written as A square plus B square plus C square is equal to minus 2. Now, AB plus BC plus CA, this can be written as ABC whole multiplied by A, 1 upon A plus 1 upon B plus 1 upon C. You know, this was equal to 0. We just calculated in the last one from 2. This was equal to 0. So this is equal to 0. That means A square plus B square plus C square also is equal to 0. Right? Why I'm doing this? You will just come to know. So e raised to power iota alpha square, e raised to power iota beta square, e raised to power iota gamma square is equal to 0, which can be written as cos e raised to power, actually not cos right now, e raised to power iota 2 alpha, e raised to power iota 2 beta, e raised to power iota 2 gamma is equal to 0, which can be written as cos 2 alpha plus iota sine 2 alpha plus cos 2 beta iota sine 2 beta cos gamma iota, 2 gamma, this is 2 gamma iota sine 2 gamma is equal to 0. Now let's separate the real and the imaginary parts. 2 alpha cos 2 beta 2 gamma plus sine 2 alpha sine 2 beta sine 2 gamma iota is equal to 0. Right? So I can write it as this, which means the real part is also equal to 0 and the imaginary part is also equal to 0. What in the question we needed to find was, okay, cos 2 alpha plus cos 2 beta plus cos 2 gamma. This is equal to 0. Here 0 is not in the option. There are 4 options, but 0 is not there in the options. So what we can do over here is we have to rethink about this sum. Let's go for this. Now this can be written as see, we had this thing from this equation. A square plus B square plus C square, this comes out to be 0. If this comes out to be 0, then if I'm using this particular equation, do you get me? If I'm putting this over here, and let's name this as equation X. So I'm putting A square plus B square plus C square in equation X, then I will get from equation X, I will get, what I had was A square plus B square plus C square plus 2AB plus BC plus CA is equal to 0. This was equal to 0, which means this was equal to 0. We just solved this, which means AB plus BC plus CA is also equal to 0. Now AB was e raised to power iota alpha, e raised to power iota beta, e raised to power iota beta, e raised to power iota gamma, e raised to power iota gamma into e raised to power iota alpha is equal to 0, which can be written as e raised to power iota alpha plus beta, e raised to power iota beta plus gamma, e raised to power iota alpha plus gamma is equal to 0. Right? So, you know this thing, this is equal to cos alpha plus beta, cos beta plus gamma, cos gamma plus alpha, alpha plus gamma plus iota sine alpha plus beta, sine beta plus gamma, sine alpha plus gamma. This is equal to 0 plus iota 0, which means this is also equal to 0 and this is also equal to 0. And this one is present in the options as option D. So this is also equal to 0, and cos 2 alpha, we just solved over here. Where it is? Yes. We just solved over here. Cos 2 alpha plus 2 beta plus 2 gamma. This was also equal to 0. So this is equal to 0, and even this is equal to 0, which means they both are equal. That means we have option D as the correct answer. Hope you understood this one, right? Let's move to the next question then. Question number 9. One of the values of minus 32 iota raised to power 2 by 5 is, all right, I'll assume x to be minus 32 iota raised to power 2 by 5. Or if I'm raising the power minus 32 by 2, you will get 1024 minus, wait. Okay, this is equal to minus 1 raised to power 2 by 5 into 32 iota. Sorry for this. Question number 9. What is the value of this given expression? Let's go. Let x is equal to minus 32 iota whole raised to power 2 by 5, which can be written as minus of 32 raised to power 2 iota raised to power 2 whole raised to power 1 by 5. This is also minus 1 raised to power 2. So this will be equal to 32 square into iota square is equal to minus 1 whole raised to power 5. 32 square is 1024 and minus 1 is this. So you can write it like this, minus 1, minus 1024 raised to power 5. This was assumed as x. So you can say x raised to power 5 is equal to minus 1024. Okay. And 1024, this also can be written as, if I'm taking to the powers of 5, this is 4 raised to power 5. So x raised to power 5 is equal to minus 4 raised to power 5, which will give you x upon 4 raised to power 5 is equal to 1. Minus 1, sorry. Okay. So, yeah. So let's take 1 on this side. You can say minus x by 4 raised to power 5 is equal to 1. Now, therefore, minus x upon 4, this is equal to cis 2n pi upon 5, where n is equal to 0, 1, 2, 3, and 4. Now, for n is equal to 4, x is equal to minus 4 cis 8 pi upon 5, which is equal to 4 cis 3 pi by 5, right? Let's check with the options. Here is option B, the correct answer. Hope you got this. Next is question number 10. If the quadratic equations this and this have the common root, then for non-zero real value of C, the sign of the expression is given by what? Let's go. So what is the condition for the common root? They have a common root. The condition for it. Condition for common root. This is C1, E1 minus C2, A2. Sorry, A1 and here is A2. C1, A2 minus C2, A1 whole square is equal to B1, C2 minus B2, C1 into A1, B2 minus A2, B1. So let's open it. Let's fill in the values actually. You know, this is A1, coefficient of x square is equal to A1, and this is B1 minus 7, C1, 3C, A2, B2, C2. So A2 is the coefficient of x square in the second, B2 is the coefficient of x, C2 is minus 5C. Let's fill in the values now. So C1 is 3C, A2 is 1, so minus C2 is minus 5C. This is 1 whole square is equal to B1 is minus 7 into minus 5 minus B2 is 1 into 3C, and A1 is 1 into B2 is 1. So this is 1 minus A2 is 1 and B1 is minus 7. So minus of minus 7 will give you plus 7. Okay, let's solve it. You will have here 3C plus 5C whole square is equal to 35 minus 3C into 8. 8C square, this is 64C square, is equal to 35 multiplied by 8 will give you, I think we are, 35C it was. I forgot to write down C over here. All right. So this is 32C into 18, or C square is equal to 32C into 18 upon 64. So you have C square is equal to question number 10. If the quadratic equation this and this have the common root, then for the non-zero real value of C, the sign of expression this is. Okay. So the two given equations are x square minus 7x plus 3c is equal to 0. So the coefficient of x square a1, the coefficient of x is b1, 3c is c1. The second equation is x square plus x minus 5c is equal to 0. A2, coefficient of x square, B2, coefficient of x, and C2, coefficient, it's minus 5c, the constant. Right. Now the condition for the common root is condition for common root can be given by C1, A2, C2, A1 whole square is equal to B1, C2 minus B2, C1 multiply A1, B2 minus A2, B1. Let's fill in the values. So C1 was equal to 3C and A2 is 1. So this gives me 3C minus 5C. Okay, this will be plus 5C whole square. Next, B1 is minus 7, C2 is minus 5C. This gives you 35C minus 1 into 3C, which is 3C, and 1 into 1 minus 1 into minus 7. This will be plus 7. Okay, this gives you 64C square is equal to 32C into 8. This will cancel at 2 and this will cancel at 4, which gives you C square is equal to 4C, or C is equal to 4. Why? Because C can't be equal to, C is not equal to 0, right? Now the given expression, this one becomes x squared minus 3x plus C becomes, now the given expression becomes x squared minus 3x plus 4 is equal to, okay, this is the expression, not an equation. Now, to find out its nature, its discriminant, you know, the formula is b square minus 4ac. The discriminant can be given as minus 3 square minus 4 into 1 into 4, which is equal to minus 7, which is less than 0. That means over here, also one thing, the coefficient of x square is equal to 1, which is greater than 0. Hence, the given expression is positive for all. Hence, the given expression is positive for all x belonging to real numbers. Okay. So that means we have option C as the correct, D as the correct answer. Hope you understood this. Let's move to the next question, number 11. So it says let fx is equal to this whole expression if x is maximum value of, m is maximum value of fx, and fx is greater than n for all x belonging to the real numbers, then the value of this expression is equal to what? Let's write down fx. This is equal to 6x squared minus 18x plus 21 whole divided by 6x squared minus 18x plus 17. All right, let's split it up. So this can be written as 1 plus 4 upon 6x squared minus 18x plus 17. Now, you know one thing, if the general equation ax square plus bx plus c, this belongs to, the interval will be minus d upon 4a comma infinity when a is greater than 0. So for this equation, 6x square minus 18x plus 17, let's find out the discriminant, which is b square minus 4ac, which is equal to, okay, b square is minus 18 square minus 4 into 6 into 17. So this 18 square is given by 324 minus 4 into 6 into 17 is 408. So this will give you, subtracting 2 will give you minus 84. So minus d upon a, 4a, is equal to minus 84 upon 4 into 6. So this will be 21 and 7 and 2. So this is equal to, that means the minus d upon 4a is equal to minus 7 by 2. So this was just a side by calculation, put it into frame. Right, let's get back to here. We were solving fx is equal to 1 plus 4 upon 6x square minus 18x plus 17. So that means over here 6x square minus 18x plus 17, this belongs to open, closed 7 by 2 minus 7 by 2, and this is equal to plus and infinity. Okay, so therefore 4 upon 6x square minus 18x plus 17 will belong to 0, 8 by 7. Question number 11, it says fx is equal to this expression 6x square minus 18x plus 21 upon, let's write it here, fx is equal to 6x square minus 18x plus 21 divided by 6x square minus 18x plus 17. If m is the maximum value of fx and fx is greater than n for all x belonging to the real numbers, then 14m minus 7n is given by. Okay. So first thing you are given that fx is this function. This can be written as 1 plus 4 upon 6x square minus 18x plus 17, right? Now one thing, if I look at the denominator, which is 6x square minus 18x plus 17, what you can say, I'll do some calculations now. See, for any general equation, ax square plus bx plus c, this belongs to the interval of minus d upon 4a comma infinity closed, when a is positive. Okay, so let's calculate for this 6x square minus 18x plus 17, the discriminant for this, which is given by b square minus 4ac, that is minus 18 square plus b square minus 4ac. So minus 4 into a is this and c is this. 18 square, 324 minus this is equal to 408, which will give you minus of 84. And minus d upon 4a will be given by minus 84 upon 4 into 6, which will be equal to 7 by 2. Okay. Right. So that means if I get back to this equation, I'll get back from here to 1. From 1, fx was equal to 1 plus 4 upon 6x square minus 18x plus 17. So here, first thing, 6x square minus 18x plus 17, this belongs to the interval of 7 by 2 infinity. If I say 4 upon 6x square minus 18x plus 17, this will belong to the interval of 0 open. 0, 8 by 7. How 8 by 7? So 7 by 2 multiplied by 4. This will be 7 by 8. So inverse of that will give you 8 by 7. Okay. Now, fx, which was equal to, let's do 1 plus this. So this will be 1 plus 1 plus 4 upon 6x square minus 18x plus 17. This will belong to 1, 8 upon 7 plus 1 will give you 15 upon 7. So from here, m is equal to 15 by 7 and n is equal to 1. You have to find out 14m minus 7n. So 14 into this, this will be equal to 30 minus 7, which is 23. So 23, that is option B, is the correct answer to the problem. Hope you understood this. Let's move to the next question. Question number 12. If alpha, beta, gamma are the roots of this equation and alpha cube plus beta cube plus gamma cube is equal to 5, then R is equal to what? So the given equation, x cube x square x plus r is equal to 0. Alpha, beta, gamma are the 3 roots. So if they are the 3 roots, sum of the roots is given by minus b upon a. B is the coefficient of x square, a is the coefficient of x cube. So that means it's minus 1. Sum of the product of the roots, alpha plus beta, beta plus gamma, alpha beta plus beta gamma plus gamma alpha is equal to c upon a, which is equal to 1. And the product of the 3 roots is given by minus d upon a, that is minus r. Right? Okay. So next thing you are given that alpha cube plus beta cube gamma cube is equal to 5. These two things are given. So let's do this. You know, alpha cube plus beta cube plus gamma cube, I'll subtract and add minus 3 alpha beta gamma. This is equal to 5. Now this whole expression can be written as alpha plus beta plus gamma into alpha square plus beta square plus gamma square minus alpha beta, beta gamma minus gamma alpha plus 3. Alpha beta gamma was equal to minus r. This is equal to 5. Alpha plus beta plus gamma, this is minus 1. Alpha square plus beta square plus gamma square plus 2 alpha beta, 2 beta gamma, 2 gamma alpha minus 3 alpha beta, 3 beta gamma minus 3 gamma alpha minus 3r is equal to 5. So this can be written as now minus 1. It will be outside. This is alpha plus beta plus gamma square minus 3 alpha beta, beta gamma, gamma alpha minus 3r is equal to 5. Minus 1 into minus 1 square minus 3 into 1 minus 3r is equal to 5, which will give you minus 1 multiply 1 minus 3 r is equal to 5. Minus 2, so 2 minus 3r is equal to 5, or r will be equal to minus 1. Okay, so that means r is equal to minus 1. We have option C as the correct answer. Hope you understood. Let's move to the next question. Question number 13. If 5 by 2 is the sum of the roots, 2 roots of this equation, then the sum of all non-real roots of the equation will be. It's a big equation. Let's write it down. 6x raised to power 6 minus 25 x raised to power 5, 31 x raised to power 4, 31x square plus 25x minus 6 is equal to 0. So let's see 6x square, 6 into x raised to power 6 minus 6. I'm combining both of them and I'll take 6 common. So this will be 6 into x raised to power 6 minus 1 minus 25x into x raised to power 4 minus 1. Then minus 31 x square minus 1. Here is plus 31 is equal to 0. Right? Now I'll take x square minus 1 common from all of them, you'll be left with 6x raised to power 4 plus 6x square plus 6 minus 25x into x square plus 1 plus 31x square is equal to 0. Now, I'll take x, this was already common, so this can be written as 6x raised to power 4 minus 25x cube plus 37x square minus 25x plus 6 is equal to 0. I'll take x square common. X square minus 1 into x square. So here will be 6x square minus plus 6 upon x square. I'll combine both of these. Minus 25 x plus 1 upon x plus 37 is equal to 0. So further, give a minute. Okay. So yeah, further x square minus 1 into x square. So I have already taken the 6 common. X square plus 1 upon x square minus 25 x plus 1 upon x plus 37 is equal to 0. So you can write it as x square into x square minus 1 whole. And see, 6 into x square plus 1 upon x square. I can write it as 6 into x plus 1 upon x square minus 2 into x into 1 upon x, right? I can write it down like this. Minus 25x plus 1 upon x plus 37 is equal to 0. Further, x square into x square minus 1. So now this thing, like you can write it as 2. This can be 6 into x plus 1 upon x whole square. So this will be 2, and when the brackets will open, this will be minus 12. 6 into minus 2 will be minus 12, and 12 will be subtracted from 37 to give you 25. Let's write it. 25 x plus 1 upon x plus 25 is equal to 0. X square minus 1. So this can be written as now further 3. I'll take, see, now this is something of the form if I'm putting x plus 1 upon x as t. So this can be written as 6t square minus 25t plus 25 is equal to 0. So let's factorize. You will have 6t square minus 15t minus 10t plus 25 is equal to 0. X square minus 1. So this will be 3t, 2t minus 5 minus 5, 2t minus 5 is equal to 0. X square into x square minus 1. So the two factors will be 3t minus 5 and 2t minus 5. But t was equal to something else. Let's write it. T was equal to x square into x square minus 1. So 3 into x plus 1 upon x minus 5. This is the first factor. And the second factor is 2 into x plus 1 upon x minus 5. This is whole equal to 0. Now, you know one thing that, see, in the question it is given that this is the sum of the roots. Okay, fine. X cannot be equal to 0 because this is not a root. Look at the equation. X is equal to 0 is not the root. So that means 3 x plus 1 upon x minus 5 is equal to 0, or 2x plus 1 upon x minus 5 is equal to 0, which gives you x plus 1 upon x is equal to 5 by 3, or x plus 1 upon x is equal to 5 by 2. So let's solve it further. You will have x square plus 1 upon x is equal to 5 by 3, which gives you 3x square plus 1 minus 5x is equal to 0. And here you will have x square plus 1 upon x is equal to 5 by 2. 2x square minus 5x plus 1 is equal to 0. So from here, the two roots of x will be, x will have the two roots as 5 plus minus root of in minus 11 upon 6. And from here, you will have the two roots of x as 2 and 1 by 2. Now the question, it was given, see, 5 by 2 is the sum of two roots of the equation. So if I'm adding both of them, I will get both of them. If you will add, you will get 5 by 2. And the question was, what is the sum of all non-real roots? So what are the non-real roots? Of course, this is a non-real root. Root of minus 11, this is not real. So sum of non-real roots will be 5 plus root of minus 11 upon 6 plus 5 of minus root of minus 11 upon 6. So on solving this, you will definitely, these two will get cancelled and you will have 10 upon 6, that is equal to 5 by 3. Okay. So this is the answer to our problem. Option C is the correct answer. Hope you understood this question. Let's move to the next question, number 14. It says if 1 plus root 2 and 2 minus iota are the roots of this equation, where B, C, D, E are rational numbers, then the roots of this equation are. What is the nature of the roots? All right. So you are given that, see, 1 plus 2, root 2 and 2 minus iota. These are the two roots. So what will be the other two roots in this case? 1 minus root 2 and 2 plus iota. Because these roots occur in the conjugate pair. Because these roots occur in the conjugate pair. Okay. Now, therefore, the given equation x raised to power 4 plus bx cube plus cx square dx plus e. So, this can be written as x square minus 1 minus root 2 root 2 over here plus 1 plus root 2 x plus 1 minus root 2 into 1 plus root 2. This whole multiplied by x, I'll take common, x square minus 2 minus iota plus 2 plus iota x plus 2 minus iota 2 plus iota. I hope you understood what I have done over here. This is the general, when you are given the roots for a cubic polynomial, this is the general equation, like from the roots, how you can derive the equation. I hope you know this already. So for the quadratic, it is always like x square minus sum of the two roots multiplied by x into product of the two roots, right? Minus sum of the roots plus product of the roots multiplied by x into x square, again sum of the another two roots plus product of the another two roots. This is what I have done over here. Okay, so using this general formula for deriving the equation from the roots, I have come to this one. Now let's solve it further. So these are the two roots, the sum of the two roots. This is the product of the two roots. This is sum of another two roots, and this is the product of another two roots. Okay, so let's solve it. You will get this one as x square. So these two things will cancel and you will have minus 2x minus 1. And sorry, this is multiply, right? Okay. So next it will be x square minus, now this time iota will get cancelled and you will have minus 4x plus 5. Hope you got this. Okay. So these are the two factors for the given quadratic polynomial. Question number 14. If 1 plus root 2 and 2 minus iota are roots of this bi-quadratic polynomial and b, c, d, e are rational numbers, then the roots of this given equation are. So you are given the two roots. Given roots are 1 plus root 2 and 2 minus iota. If these are two given roots, then the other roots will be 1 minus root 2 and 2 plus iota. Now, why is that? Because these type of roots occur in conjugate pair. Because these roots occur in conjugate pair. Okay. So now the given equation was x raised to power 4 bx cube cx squared dx plus e is equal to 0. We are given, we have all the four roots for this equation. This is a biquadratic equation. So we have all the roots. Let's frame the equation from the roots. I hope you know this thing, how we are going to do this. So this will be given by x square minus sum of the roots 1 plus root 2 plus 1 minus root 2 into x plus product of the roots. Okay. And the second one will be, this is in the multiplication, x square minus, now the other two roots are 2 minus iota plus 2 plus iota into x plus 2 minus iota into 2 plus iota. Okay, this will be square brackets now. Okay, so when you will open this, see these two will cancel and similarly iota and iota will cancel. You will have here x square minus 2x and solving this you will have minus 1 because a square minus b square, so 1 minus 2 will give you minus 1. Next is x square minus 4x plus 5. So let's multiply them. You will get x raised to power 4. You will solve the whole thing. You will get x raised to power 4 minus 6x cube plus 12x squared minus 6x minus 5. Now let's compare it with the given equation, which was x raised to power 4 bx cube cx squared dx plus e. So from here, you easily see what is the value of b. Minus 6. C is equal to 12 and D is equal to minus 6. B, C, D, like B is minus 6, C is 12 and D is minus 6. What we had to find out? Okay, let's frame this equation now. Now the given quadratic equation was, what was that equation? Given equation bx squared plus cx plus t is equal to 0. That makes it minus 6x squared plus 12x minus 6 is equal to 0, or x squared minus 2x plus 1 is equal to 0. So this is actually equal to x minus 1 whole square is equal to 0. So what is the nature of the roots over here? They are, see, it is x minus 1 is square is equal to 0. So the roots are real and equal. That means we have option B as the answer. Hope you understood this. Let's move to the next question. Question number 50. Let the transformed equation for this equation so that the term containing the cubic power of x is absent be this. All right, you have to find out the value of b, which is given in this expression. Okay, let's go. So let's replace in this question x by, replace x by x plus k. So this equation will become 2 into x plus k whole power 4 minus 8x plus k whole power 3, 3x plus k whole square plus 1 minus 1 is equal to 0. So let's open up. This x plus k whole raised to power 4 can be seen as x plus k square into x plus k square. So I'm opening it right away. 2x square plus k square plus 2kx into x square plus k square plus 2kx minus x into x plus k into x square plus k square plus 2kx minus 3x square plus k square plus 2kx minus 1 is equal to 0. Okay, so let's solve it further. Opening up, this can be written as 2 will be outside, x raised to power 4 plus x square k square 2kx cube k square x square. You have to do this very carefully because a single mistake will disturb the whole sum. K raised to power 4 plus 2k cube x plus 2k x cube 2k cube plus 4k square x square. Now minus 8 x cube plus 4 this kx square plus k square x plus k cube plus 2kx square plus 2k square x plus 3. This is, yes, sorry, this is plus, right? Yeah. Okay. Plus 3 x square plus 3 k square plus 6 kx. No, wait. Plus 6 plus, sorry, this is 6kx. Yes, I was mistaken. Okay. 6kx minus 1 is equal to 0. Further, now I will combine the whole x raised to power 4. I'll segregate all the coefficients. So this will be 2x raised to power 4 plus 8k minus 8 into x cube plus 12k square minus 24k plus 3 into x square plus 8k cube 24k square 6k into x plus 2k raised to power 4, 8k cube, 3k square minus 1 is equal to 0. Now in the question it was given that the cubic power of x is absent in this case, which means according to the question, coefficient of x cube is equal to 0, which is 8k minus 8, 0, which gives you k is equal to 1. So putting k is equal to 1, what the equation will become? 2x raised to power 4 minus 9x square minus 10x minus 4 is equal to 0. You have to find out the value of b, and b is equal to minus 9. Right? So you got your answer as minus 9. Let's check. We have option C as the correct answer. Hope you understood this. Next is question number 16. The question says A, B, C are 3 particular speakers among 10 speakers of the meeting. The number of ways of arranging 10 speakers on the dais in a row so that the 3 speakers, all the 3 speakers, which are A, B, and C, do not sit together. Okay, so first of all, the total number of ways. Total number of ways in which 10 speakers can sit. Is given by 10 factorial, and number of ways in which all 3 are together. Number of ways in which all 3 are together. This will be given by 3 factorial into 8 factorial. Okay, so we had to find out in which they are do not sit together. So required number of ways will be given by 10 factorial minus 8 factorial into 3 factorial, which can be given by 90 into 8 factorial minus 6 into 8 factorial, which is 84 into 8 factorial, which is option D. Hope you understood this. Let's move to the next question, number 17 then. Okay, the exponent of 6 in 72 factorial is, one thing, 6 can be written as 2 multiply 3, right? Highest power of 2 in 7 raised to 72 factorial. Highest power of 2 in this is given by 72 upon 2, 72 upon 2 raised to power 2, 72 upon 2 raised to power 3, 72 upon 2 raised to power 4, and 72 upon 2 raised to power 5, then 72 upon 2 raised to power 6, which is equal to 36 plus 18, 9, 4, 2, 1. That is equal to a total of 70. Similarly, highest power of 3 in 72 factorial. Highest power of 3 in 72 factorial is given by 72 upon 3 plus this plus this, which is equal to 24 plus 8 plus 2, that is equal to 24. Therefore, exponent of 6 in 72 factorial is exponent of 6 in 72 factorial is 34. Why? Because 2 raised to power 34 into 3 raised to power 34 is equal to 6 raised to power 34. Right? That means we have 34 as the answer. Option A is the correct answer. Hope you got that. Let's move to the next question, number 18. If the fourth term of this expansion is minus 20, then xy is given by what? Okay, you have to find out the fourth term. So T4 is actually T3 plus 1. This is given to you as minus 20. T3 plus 1 can be written as 6C3 x by 2 raised to power 3 minus 2y by 3 raised to power 3. This is equal to minus 20. So 6C3, this is equal to 6 factorial, 6, 5 into 4 into 3 factorial, which will be cut by the 3 factorial in the denominator. Okay, let's write down. Multiply x cube upon 8 multiply minus 8 y cube upon 27. This is equal to minus 20, right? So this minus 20 and this will cancel, the minus sign, this will cancel, 8 will cancel, 3 factorial will cancel, 3, 2 will cancel with the 6. And I will get x cube y cube is equal to 27, which gives me xy is equal to 3. So I have the answer xy is equal to 3. Option B is the correct answer. Hope you understood this. Next is question number 19. Integral problem before us. It says if integral of this is equal to this whole expression, then a plus b plus c is equal to what? Okay, so very first thing, I'll pick up the LHS. I'll ignore the integral right now. I'll focus on solving this. So x plus 3 upon x minus 1 square 2x minus 1. I can write it down like this. P upon 2x minus 1 plus q upon x minus 1 r upon x minus 1 square. So ignoring the, I'm taking the LCM and the denominators will be cut down. You will be left with x plus 3 is equal to p into x minus 1 square plus q into 2x minus 1 into x minus 1 square plus r into 2x minus 1. Now let's put x is equal to 1. If I'm putting x is equal to 1, so you will have 4 is equal to, this will cancel out. This will cancel out and you will be left with r into 1. So r comes out to be 4. Now let's put x is equal to 1 by 2. So when you will put x is equal to 1 by 2, this will be 7 by 2 plus p into minus 1 by 2 square, and q will be equal to, like, this will be 0, right? So this will be 0 plus r 1 by 2. This is 1 minus 1. So ultimately you will get the value of p is equal to 14. Now let's put x is equal to 0. So when you put x is equal to 0, solving the whole thing, you will get only q is left. You will get q is equal to minus 7. You can solve it. You will find out that q will come out to be minus 7. Now the whole thing has become pretty easy, right? The given integral was equal to, it was x plus 3 upon x minus 1 square to x minus 1 dx. This can be written as 14 upon 2x minus 1 dx minus 7 upon x minus 1 dx plus 4 upon x minus 1 square dx. Let's find out the integral. This will be equal to 14 into log of 2x minus 1 multiplied by 1 by 2 minus 7 log of x minus 1 plus 4 minus 1 x minus 1 upon x minus 1. So plus the constant k. Okay. So let's write it properly. This can be written as minus 4 upon x minus 1 plus 7 log 2x minus 1, 7 log x minus 1 plus k. Now let's compare it with what was given in the question, this thing, the RHS. Write it down. So this was equivalent to a upon x minus 1 plus b log of 2x minus 1 c log of x minus 1 plus k. So comparing them, you will get the value of a is equal to minus 4, b is equal to 7, c is equal to minus 7. So a plus b plus c. Now, adding all of that, you will get the value as minus 4. So minus 4 is the answer to the question. Let's check. We have option C as the answer. Hope you understood this question. Let's move to the next question, number 29. Okay, so now we have again similar type of problem, but the integrals are not there. So x squared plus 7, let's write it down. You are given x squared plus 7 upon x squared plus 1x minus 2 is equal to a upon x minus 2 plus bx upon c upon x squared plus 1. Let's find out the LCM on the right hand side and I will cut down the denominators. You will get x squared plus 7 is equal to a into x squared plus 1 plus bx plus c into x minus 2. So on putting, you have this thing. Now let's put x is equal to 2. You will find out the value of a comes out to be, this will be 11 is equal to a into 5 plus 0, which gives you a is equal to 11 upon 5. Now let's put x is equal to 0. So this will be 7 plus 11 by 5 plus c into minus 2, which on solving will give you the value of c as minus 12 by 5. Now let's put x is equal to 1. So if x is equal to 1, this is equal to 8 is equal to a into 2, which is actually equal to 11 by 5 into 2 plus 1. So this is equal to B plus C. So BC was minus 12 by 5 into minus 1. Which on solving, you will put the value of A as 11 by 5. So ultimately, you will get the value of C as minus 6 by 5. Now you have to find out the required determinant. We know all the values of A, B, C and ABC. Required determinant is 11 by 5 minus 6 by 5 minus 12 by 5 and 2 by 5. This is equal to 22 by 25 minus this, which is minus 50 upon 25, which is equal to minus 2. So you have minus 2 as the answer to the question. Option D is the correct answer. Hope you understood this. Let's move to the question number 21. So if tan 15 and tan 30 are the roots of this given equation, x squared plus bx plus q is equal to 0, then you have to find out the value of pq. Okay, so you know one thing, the sum of the roots is equal to minus b upon a. So tan 15 plus tan 30 is equal to minus b. This is a, b and c, right? A is 1, b is p and c is q. And the product of the roots is equal to c upon a, which is equal to q. Now let's multiply both of them. You will get minus pq is equal to tan 15 into tan 30, tan 15 plus tangent of 30. Tan 15 is equal to 2 minus root 3. And this is equal to 1 upon root 3. This whole is multiplied by 2 minus root 3 plus 1 upon root 3. So this will be 2 minus root 3 upon root 3 whole multiplied by 2 root 3 minus 3 upon root 3. This is equal to 2. Okay, wait. All right. So I'll take root 3 common from here. 2 minus root 3 upon root 3 multiply root 3, 2 minus root 3 upon root 3. This will cancel. 2 minus root 3 upon root 3 into 2 minus root 3, which will be square. So a square plus b square minus 2ab whole divided by root 3. Which will be equal to 7 minus 4 root 3 upon this. Actually, I did a mistake over here. This 1 was left by mistake. So here is supposed to be plus 1 as well. Okay, so this is equal to, the whole sum will change now. Let's write it down. I'm repeating. Let's undo everything. Okay, so I'm almost done with undoing it. Okay, so here was supposed to be plus 1 as well. This is 2 minus root 3 upon root 3 and 2 root 3 minus 2 upon root 3. So let's multiply this. You will get 4 root 3 minus 4 minus 2 into 3, that is equal to 6 plus 2 root 3 whole divided by 3. So this will be equal to minus 10 plus 6 root 3 upon 3. This was equal to minus PQ. And PQ will be equal to 6 root 3 minus plus 10 upon 3. Okay, or 10 minus 6 root 3 upon 3. So this is the answer to our question. Let's check. We have option B as the correct answer. Hope you understood this. Next is question number 22. So cos x plus cos y is equal to P, sin x plus sin y is equal to Q. Then cos x minus y upon 2 is equal to. So, okay, what we'll do, I'll square both of these. Let's name this as 1 and 2. Squaring and adding 1 and 2. So let's do this. You have cos square x cos square y plus 2 cos x cos y plus sin square x sin square y 2 sin x sin y is equal to p square q plus q square. All right. You know cos square x plus sin square x is equal to 1. So this plus this and this plus this. You have 2 plus 2 cos x cos y 2 sin x sin y is equal to p square plus q square, which gives you 2 plus, I'll take 2 common from here. So 2, this is the form cos x cos y plus cos sin x sin y is the formula for cos x minus y. P square plus q square. So this will be, I'll take 2 common, 1 plus cos x minus y is equal to p square plus q square. But in the question, I'm asked for x minus y upon 2. Okay. So this will be 2 into 2 cos square x minus y upon 2 is equal to p square plus q square. Or you will have cos square x minus y upon 2 is equal to p square plus q square upon 4. Or cos x minus y upon 2 will be plus minus p square plus q square whole upon 2. Let's check with the options. I have option A as the answer. Hope you understood. Let's move to the next question, number 23. Okay, so this question says a plus b plus c is equal to 3 pi by 2 and 4 sin a sin b sin c plus cos 2a plus cos 2b cos 2c is equal to what? One thing only is given, that a plus b plus c, the sum of the three angles, is equal to 3 pi by 2. Now I'll pick up this portion of the sum. Cos 2a, 2b and 2c. This is equal to, so I'm combining them, cos 2a plus 2b. This is written as 2 cos 2a plus 2b whole divided by 2 into cos 2a minus 2b whole divided by 2 plus cos 2c. So see, 2 will cancel from here. 2 will be taken common. A plus b. I'll be left with 2 cos a plus b. So cos a plus b can be written as 3 pi by 2 minus c into cos a minus b plus cos 2c. Cos 3 pi by 2 minus c is actually equal to minus sin c into cos a minus b. Okay, cos 2c can be written as plus minus 2 sin square c plus 1. I'll take sin c common now. Minus 2 sin c cos a minus b plus sin c plus 1. Okay, so minus 2 sin c. Now cos a minus b, and I'm left with here this. I can't do anything with a minus b, but c can be definitely written as 3 pi by 2 minus a plus b plus 1. Okay, so this is minus 2 sin c brackets cos a minus b. So sin 3 pi by 2 minus a plus b can be written as minus cos a plus b plus 1 minus 2 sine c. So cos a minus b minus cos a plus b, this is equal to 2 sine a sine b plus 1. This is equal to minus 4 sine a sine b sine c plus 1. And now I will fill in the given equation, this one. Okay. The given equation was to find was 4 sine A sine B sine C plus cos 2A plus cos 2B plus cos 2C. We find out the value for that as this. Let's fill in. Minus 4 sine A, sorry, not plus, sine B sine C plus 1. This will cancel and I'll have 1 as the answer. But there is no 1 in the options. So what shall I do? If I look at the first option, sine A plus B plus C, I'm solving it here. Sine minus sine A plus B plus C can be written as minus sine 3 pi by 2. And 3 pi by 2 is equal to minus 1. So that is equal to 1. That means indirectly I have option A as the answer. Hope you got that. Let's move to the next question, number 24. So e raised to power 4x plus e raised to power minus 4x plus 14 divided by 4 multiplied by e raised to power x minus e raised to power minus x whole square is equal to. So this whole expression, I can write it like this. E raised to power 2x minus e raised to power minus 2x whole square plus 2 plus 14 whole divided by 4 into e raised to power x minus e raised to power minus x whole square. Right? I can do this. Now, I'll split it up. This is actually equal to 16. Let's write it. E raised to power 2x plus, minus e raised to power minus 2x whole square plus 16 divided by 4 e raised to power x minus e raised to power minus x whole square. Splitting up, you can write it as e raised to power x plus e raised to power minus x square upon 2 actually, upon 2 square. I'm connecting this 4 with one of this. So square plus 4 upon e raised to power x minus e raised to power minus x whole square. Okay. Now I will not touch this one. This will remain same. Upon 2 square. Okay. And now this further can be written as e raised to power x plus e raised to power minus x square minus e raised to power x minus e raised to power minus x square whole divided by e raised to power x minus e raised to power minus x whole square. Okay, so further, this is e raised to power x plus e raised to power minus x square. I'll write it as 4 only. Minus 1. I'll opening this. So minus 1 plus e raised to power x plus this whole square upon e raised to power x minus this whole square. Further, this is equal to e raised to power x plus e raised to power minus x upon 4. This is square plus e raised to power x plus e raised to power minus x square. Okay, I'll make some changes in the last few steps. So here was minus 4, right? This will be minus 4 plus e raised to power x plus this whole square upon e raised to power x minus e raised to power minus x whole square. So when you will open this up, this will change up into e raised to power x minus e raised to power minus x whole square. I hope you know this, like how does this change? minus 2 will come inside, and it will be changed like plus 2 minus 4 will become minus 2, and this term will become e raised to power x minus e raised to power minus x whole square upon 4. Okay, this is same. I will not change this. E raised to power minus x square. Okay, so further, this is equal to e raised to power x minus e raised to power minus x upon 2 square plus e raised to power x plus e raised to power minus x upon e raised to power x minus e raised to power minus x whole square. And this is equal to sine h square x plus cot h square x. That means let's check with the options. Option A is the correct answer. Hope you got that. Next is question number 25. It says if tan hx is equal to 1 by 2, then what is the value of this expression? Okay. So tan hx is 1 by 2. You know, sec h 2x is actually equal to 1 minus tan square hx 1 plus tan square hx. So this is equal to 1 minus 1 by 4 upon 1 plus 1 by 4, which will on solving give you 3 by 5. Similarly, sine h2x is equal to 2 tan hx minus this. So this is equal to 2 into 1 by 2 whole divided by 1 minus 1 by 4, which will give you 4 by 3. Okay, so let's subtract the two. Very easy question actually. You have to just subtract these two. 1 and 2. Subtracting 1 and 2, you will get sine h2x minus secant h2x is equal to 4 by 3 minus 3 by 5, which is equal to 11 by 50. So option B is the correct answer. Hope you got that. Let's move to the next question. Question number 26. In a triangle ABC, if A is acute, C is obtuse, sine A is given by this, A and B values are given, you just have to find out the value of C. Pretty easy question. We are given many of the things. So let's go. You are given sine A is this, which can be written as root of 27 upon 4. You know, cos A is equal to 1 minus root of 1 minus sine square A, which is equal to root of 1 minus 27 upon 14 square. So that is equal to 196. This is equal to 196 minus this. So you will have 961. 196, which will be 13 by 14. Right. Now, by the cosine rule, you have cos A is equal to B square plus C square minus A square upon 2BC. We have all the values. Cos A was equal to 13 by 14. And B square is 5 and A 3. Okay. So 5 square, 25. C I have to find out. Minus 9 upon 2BC. B was equal to 5. So 10C. Okay. Let's do the cross multiplication. So 130C is equal to 25 into 14. This will be equal to 350, right? Let's check. Okay, 100. Yeah, 350. So 350 plus 14C square minus 126. So I think that's correct. Yes. Okay. So solving this, you will have I'll divide both the sides by 2. So you have 7c square minus 65c and plus 112 is equal to 0. Now let's split the middle term. You will get 7c square minus 49c minus 16c plus 112 is equal to 0. The two factors will be c minus 7 and 7c minus 16 is equal to 0, which gives you c is equal to 7 or 16 by 7. Now, according to the question, c is obtuse is okay. Because C is obtuse, that means angle C is obtuse. It's given in the question. That means C is greatest, right? 16 by 7 and 7, obviously C's value will be 7 because angle C is obtuse and a side opposite to the greater angle is always the greatest. That means we have C as the 7. Option B is the correct answer. Hope you got that. Then let's move to the next question, number 27. If delta denotes area of the triangle ABC, then B sin C plus C sin B multiply B cos C plus C cos B is equal to. Let's write it down. B sin C plus C sin B multiply B cos C cos B. This is equal to B sin C plus C sin B multiply by A by projection formula. Which is equal to AB sin C plus AC sin C, sin B, sorry. That is equal to 2 delta plus 2 delta. Now why? Because delta is equal to half of AB sin C and delta is also equal to half of AC sin B. That means 4 delta is the answer to the question. Option D. Hope you understood. Next is question number 28. Let A be the area of in circle and A1, A2, A3 be the areas of X circles of the triangle. If A1 is equal to 4, A2 is equal to 9, A3 is equal to 16, then you have to find out the value of A. All right. So first thing, so one thing, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Because you know one thing that A is equal to area of the triangle, area is equal to pi R square. And from here, R is given by A upon pi. Question number 28, let A be the area of in circle and A1, A2, A3 be the area of X circles of the triangle. Then if A1 is 4, A2 is 9, A3 is 6, you have to find out the value of A. One thing A is equal to area of in circle. A is equal to pi R square. From here, R can be given by root of A upon pi. Correct? Therefore, R1 is equal to root of A1 upon pi. R2 is equal to root of A2 upon pi. And R3 is root of A3 upon pi. And you know one thing, 1 by R is equal to 1 by R1 plus this plus R3. So that means root of A upon pi is equal to root of A1 upon pi plus, sorry, this is 1 upon R, right? So there's a slight change. This will be written as root of pi upon A is equal to root of pi upon A1 plus root of pi upon A2 plus root of pi upon A3. All right. So Root pi will cancel from all the numerator and I'll be left with 1 upon root a is equal to this plus 1 upon root of a2, 1 upon root of a3. So this. I know a1 is given to you in the question as 4. So this will be 1 by 2. This is a2 is 9. So this is 1 by 3 and a3 is 16. So this is equal to 1 by 4. So on solving, this will give you 13 by 12. 1 by root a, or root a will be equal to 12 upon 13, or a will be equal to 144 upon 69. So 144 upon 169 is the option, sorry, it's option D. So option D is the correct answer. Hope you got that. Next is question number 29. So it says if 3 iota, sorry, not iota, 3i minus 5j plus 2k. So this is first factor, second vector, and third vector, and fourth vector are the position vectors of A, B, C, D respectively. Then the angle between AB vector and CD vector is, let's find out AB vector first. So AB vector is given by 7i plus 2j minus 4k minus 3i minus 5j plus 2k, which is equal to 4i plus 7j minus 6k. Similarly, CD vector is minus 7i minus 17j plus 16k minus I minus 3j plus 4k, which is minus 8i minus 14j plus 12k. Now, the angle between them, for that I'll have the dot product of both of them, AB and CD. So this will be given by 8 into minus 8 into 4, this is equal to minus 32. 7 into minus 14, minus 98. Minus 6 into 12, minus 72. This is equal to minus 202. So modulus of AB is given by 4 square plus 7 square plus 6 square, which is equal to root of 101. Also, CD is 8 square, 14 square, and 12 square, which is equal to root of 404. Now, let theta be the angle between them. Let theta be the angle between them. So, cos theta is equal to this upon this. So, okay, so this is, sorry, not the vectors. This is a determinant actually. This is equal to minus 202 upon root of 101 multiply root of 404. Which is minus 202 upon, I'll take 2 common from here. 4 will be taken outside. So root of 4 is 2. And this is multiplied by 101. This is equal to minus 1. That means cos theta is equal to minus 1, which gives you theta is equal to pi. So this is the angle between both of them. Pi, that is option D, is the correct answer. Hope you understood this. Let's move to the next question then. Question number 30. If A is this vector, B is this vector, C, D. These are 4 points in the space such that AB is equal to XAC plus YAD for some real numbers. X is not equal to 0, Y is not equal to 0. Then you have to find out the value of 17 lambda plus 9. All right. So let's write down here given that, first of all, let's find out AB. AB will be given by lambda minus 2i plus 4j plus 5k. Similarly, AC will be given by minus 6I plus 2J plus 3K. Now, AD. Yes, we need AD also. Okay. Now, AD will be given by minus 3I minus 3J plus 4K. Now, the given one is this. Given is AB is equal to XAC plus YAD. And one thing, such that these are real numbers. Okay. So, this shows that AB, AC, and AD, they are coplanar. Sorry. AB, AD, and AC are coplanar. That means the determinant of them, that is lambda minus 2, 4, 5, minus 6, 2, 3, minus 3, minus 3, and 4 is equal to 0. Determinant is 0. Let's find out a determinant now. So, this is 8 plus 9. This is equal to 17 lambda minus 2. Minus 4 into minus 24 plus 9. This is equal to minus 15 plus 5 into 18 plus 6. That's equal to 24. This is equal to 0. So 17 lambda minus 34 plus 60 plus this is 120. This is equal to 0. So 17 lambda is equal to 180 minus 34. Okay, this will be 146 upon 17. Lambda is equal to this, 186 upon 17. What we had to find out? 17 lambda plus 9. Okay, 17 lambda plus 9. So this is equal to 17 into lambda plus 9. So 17 into 146, not 146, sorry. 17 nines are. This is equal to 153 upon 17. So this will cancel. And question number 30. If A is this vector, B is this vector, C is this, D is this, are the 4 points in space such that this equation is true. For some real numbers, X and Y not equal to 0, you have to find out the value of 17 lambda plus 9. Okay, so first thing, I need AB. AB is given by lambda minus 2I plus 4J plus 5K. Similarly, AC will be given by minus 6I plus 2J plus 3K. AD is equal to minus 3I minus 3J and 4K. Now, let's move according to the given equation. AB is equal to X times AC plus Y times AD, which means AB, AC, and AD are coplanar. If they are coplanar vectors, that means their determinant, if I find out, this will be 0, which says lambda minus 2, 4, 5, minus 6, 2, 3, minus 3, minus 3, and 4 is equal to 0. So this is lambda minus 2. 8 plus 9, this will be 17 plus, not plus, sorry, minus 4. Minus 24 plus 9 will give me minus 15 plus 5 into minus 18 plus 6, 24 is equal to 0. So lambda minus 2 into 17 plus 60 plus 120 is equal to 0, which gives you lambda is equal to minus 180 upon 7, 2. Okay, this is the value of lambda. We had to find out. To find was 17 lambda plus 9. So 17 Lambda was 2 minus 180 upon 17 plus 9. Which on solving will give you 17 into 11 minus this. So 17 11s will give you 187. 187 minus 180, this will be 7 upon 17. So the answer is equal to 7. Right. Option C is the correct answer. Hope you got that. Then let's move to the next question, number 31. Let a plane P has the points I, J and I plus J plus K. Let L be the line through the point A and parallel to this vector. If the plane P and line L intersect at point this, then the distance from A to B is 3 units. Then equations of the normal to the plane P through A are. Now, here equation of the line. Since it passes through B032, therefore this will be framed as x upon 1 is equal to y minus 3 upon minus 1 is equal to z minus 2 upon 1. Now, any point on this line can be given by on this line can be given by, if I'm taking x as k, the value of y will be minus k plus 3 and z will be k plus 2. Therefore, I'll assume A to be equal to k minus k plus 3, k plus 2, and B is already given to you as 0, 3, and 2. Using this, AB is given to you as 3 units. It's given to us. So let's find out AB. This will be given by k square plus minus k square. This will be k also, and this will be also k square. This is equal to 3. So 3k square, this is equal to 3 square, which gives you k square is equal to 3, or k is equal to plus minus root 3. Now, normal to the plane is given by I, J, K. This is 1, minus 1, 0, and 0, 1, 0, 1. So using this, you have I into 1 minus J into 1 again plus K into 1 again. So this is equal to, this is minus 1, minus I minus J plus K. Now the direction ratios of the normal will be given by direction ratios of normal are 1, 1, minus 1. And A will be equivalent to root 3 minus root 3 plus 3 and root 3 plus 2. Or it can have, see, this was equal to plus minus root 3. So A can also be equivalent to minus root 3, root 3 plus 3, or minus root 3 plus 2. Using this, equation of the normal will be equation of normal is x minus root 3 upon 1, y plus root 3 minus 3 upon 1, z minus root 3 minus 2 upon minus 1. Let's check with the options. Okay. I don't have any option in this, so that means we have none of the above, option E as the answer. Hope you got that. Next is question number 32. It says let A be this vector and B be the two vectors such that A dot B is equal to 1, cos AB is equal to 1 by 3, components of B with respect to I, J, K be the integers. And the number of possible vectors that represent B are. So first of all, I'll assume B to be Xi, Yj, and Zk, where X, Y, Z, they are integers. Correct. Now, A vector is given by I plus J plus K. This is A vector, and A dot B is equal to X plus Y plus Z. This is given to us as 1. I'm writing down 1. Also, cos of A dot B is equal to 1 by 3. This is given to us. You know one thing, A dot B is equal to A modulus, B modulus into cos of angle between them, which is cos of angle between them is given to you 1 by 3. So 1 by 3. This is equal to 1, right? According to this equation. So A is equal to modulus of A vector is equal to root of 1 plus 1 plus 1, that is equal to root of 3. So root of 3 into this modulus of B into this, right? This is equal to A dot B, which is 1. So that means B is equal to root of 3. Next, what you had to find out, the number of possible vectors that represent B. So that means X square plus Y square plus Z square is equal to 3. Right? Because modulus of B is equal to root 3, which gives you root of X square plus Y square plus Z square is equal to root 3, which gives you X square plus Y square plus Z square is equal to 3. Therefore, the possible values of X, Y, Z can be possible values of X, Y, Z are 1, 1, minus 1, 1, minus 1, 1, and minus 1, 1, 1. So that means there are 3 vectors possible. Let's check with the options. I have option C as the correct answer. Hope you understood this. Next is question number 33. Okay, it says let pi 1 be the plane passing through this point, vector is given by this, and perpendicular to this vector. Pi 2 be the plane passing through this and perpendicular to this vector. Theta is the angle between the planes pi 1 and pi 2, and cos theta is given by this. Then the integral value of A is what? Okay, first thing, it's given pi 1 be the plane which is passing through this and it is perpendicular to this vector. So pi 1 is R into A I plus 2J minus 3K, right? This is equal to question number 33. Let pi 1 be the plane passing through this point and perpendicular to this vector. Pi 2 be the plane which is passing through this point and perpendicular to this vector. Theta be the angle between these two planes, and cos theta is given by minus root 3 by 7. You have to find out the integral value of A. All right. So first, you are given the pi 1 plane which is passing through this point and perpendicular to this vector. So pi 1 can be given by R into AI cap 2J minus 3K cap. Now this is equal to, this is 2 into A, 2A, minus 1 into plus 2 will give you minus 2, plus 1 into minus 3 will give you minus 3. So this is equal to 2A minus 5. Similarly, pi 2, the second plane, this is equal to the same R, multiply I minus 2J plus K. Now this is equal to I multiply I, which is equal to 1 minus 2 plus 2 into minus 2, this will give you minus 4, and minus 1 into plus 1, this will give you minus 1. So this is equal to minus 4. Correct. Next, it's given that cos theta, which is the angle between these two planes, it is given to be equal to minus root 3 by root 7. Right? or you can say this is equal to this. Okay. Now that means cos theta is equal to A dot B upon the modulus of both of them. So let's do, these two vectors were AI to J minus 3K dot I cap minus 2 cap plus J cap K cap whole divided by mod of A square plus 2 square minus 3 square multiply 1 square minus 2 square and 1 square. So this is, let's do the multiplication. So you have A into 1, that's A, plus 2 into minus 2, this will give you minus 4, minus 3 into this is equal to minus 3. So this is equal to A squared plus 4 plus 9, that is equal to A squared plus 13 multiplied by 1 plus 4 plus 1, that is equal to 6. A minus 7 upon A squared plus 13 into root of 6. This is equal to minus root of 3 by 7. Now, let's write it here. Minus 3 by this is equal to A minus 7 upon root of A square plus 13 multiply root of 6. Let's do the squaring on both the sides. You will get 3 by 7 A square plus 13 multiply 6. This will give me 18 A square plus 13 is equal to 7A minus 7 whole square. So this is 18A square plus 18 13s will give you, give me a minute, let me calculate. $234. This is equal to 7A square plus 49 into 7 will give you 441 minus 14. So this is equal to minus 98. Minus 98A. So this is going to give me, let's do the subtraction, 11A square plus 98A minus 109 is equal to 0. So when you will factorize this, you will get the two factors as 11A plus 109 into A minus 1. So that means A is having two values, either it is 1 or minus 1 by 9 upon 11. Now in the question, what is the integral value of A? That means this is not an integer. We have A is equal to 1 as the answer to this question. So option D stands to be the correct answer. Hope you got that. Next is question number 34. If A and B are two factors such that A is equal to this and B is equal to this, and A cross B is given by 5 root 17, then what is B equal to? Okay. Fine. So first is A vector is 2I plus 2J plus PK. Let's write. And B vector, it's not given. The modulus of B is given. So it is 7. Also, you are given that A vector dot B is equal to 4. And this is this. Okay. Now, if I find out the modulus of A, this is root of 2 square 4 plus 2 square 4 plus P square, which gives you root of 8 plus P square. And you are given the modulus of B is equal to 7. Also, you know, this cos theta, this is given to you 4 from here. Okay, right? So that means root of 8 plus P square multiply 7 into cos theta. Cos theta. See, from here, I don't have the cos theta right now, so I'll skip this step right now. Let it be till here only. Now, second thing you are given that modulus of A cross B is equal to 5 root 17. Actually, this is equal to A, B, sine theta. This is equal to this. right? So let's divide both of them. Divide 1 and 2. You will get 4 by, or you can say equating also. You will say 4 by cos theta is equal to 5 root 17 by sin theta, which will give you sin theta upon cos theta is this. That means tangent of theta is equal to this value, right? So if you got the value for tangent, see, this is a tangent, this is the perpendicular, and this is the base. So you can find out the hypotenuse because I need to find out the value for cos theta. So let's go for finding out that value. From here, okay. Question mark square is equal to 5 root 17 square plus 4 square, which is equal to 25 into 17. Question number 34. If A and B are the two vectors such that A is given to be this vector and mod of B is this, the dot product of both the vectors is 4, cross product of both the vectors is 5 root 17, then the value of P is. So, okay, let's write down A vector first. It is given to be 2i plus 2j plus pk. And the mod of this vector is root of 4 plus 4, 2 square plus 2 square plus p square, which is equal to root of 8 plus p square. And the second thing you are given that mod of b vector is equal to 7. Next, you are given A dot B vector is equal to 4. Okay, let's write down. This is equal to 4. And you know, this is equal to mod of A, B into cos theta. That is the angle between both the vectors. This is given to you as 4. This is equal to root of 8p square multiply 7 multiply cos theta is equal to 4. Yes, okay. So let's name it as number 1. Now let's pick up the second thing, which is the cross product of both the vectors. This is equal to 5 root 17. So this is A, B mod into sine of angle between the two. So this is the one. And this is equal to root of 8 plus p square multiplied by 7 is into sine theta is equal to 5 root 17. Now let's divide, let it be 2. Let's divide 1 and 2. Or actually these two will cancel out, right? So you will have sine theta upon cos theta is equal to, like I'll say dividing 1 and 2. Sine theta upon cos theta is equal to 5 upon root 5 into root 17 upon 4. That is equal to tan theta actually. Okay. So I have the value for the tan theta. I can easily find out the cos theta now. 5 root 17 upon 4. So using the Pythagoras theorem, I can find out the hypotenuse. This is given by square is equal to 5 root 17 square plus 4 square. So this will give me 25 multiply 17. That's equal to 425 plus 16. So hypotenuse is actually root of 441. That is equal to 21. So I got the hypotenuse as 21, which means from this equation, from equation 1, from equation 1, 4 upon A mod upon B mod, or wait, that was equal to root of 8 plus p square multiply 7 multiply cos of theta was equal to what it was equal to 4. Okay. So this multiply cos theta will be given by 4 upon 21. This is equal to 4. This 4 and 4 will cancel, and this will cancel. So you will have 8 plus p square is equal to 3 square, or p square will be equal to 1. That means the p's value is got to be plus minus 1. Okay. This is the value of p which was required, and option C is the correct answer. Hope you got that. Let's move to the next question. Question number 35. The mean deviation from the mean of this discrete data is what? Let's find out the mean of this data first. Mean, you know, it's given by the sum of terms. That's 1 plus 3 plus 4 plus 7, 11, 18, 29, 47 plus 78. Whole divided by number of terms, which is equal to 9. This one solving will give you 190 by 198 by 9. That is equal to 22. So this is the value for the mean. Now you have to calculate the mean deviation. Let's go. So this is the column xi, and this is xi minus this. We have to calculate. First of all, calculating the mean deviation, let's first calculate the deviation, which is given by xi minus x bar. Okay. So these are the values: 1, 3, 4, 7, 11, 18, 29, 47, and 78. And the mean was equal to 22. So basically 1 minus, okay, this is bar over here. Mod is there. Okay, so 1 minus 22 will give you minus 21, and mod of that will give me 21. Next will be 19, 18, 15, 11, 4, 7, 25, and 56. So we have to find the sum of it. Let's do the sum of it. You will get 176. Now this is the mean, and mean deviation will be 176 upon 9. So this is the answer. That is the number of terms, 176 upon the number of terms. That means option C is the correct answer. Hope you understood. Question number 36. When two dice are thrown, the probability of getting a prime number on one die and composite on another one is. Pretty easy question actually. What are the prime numbers on the dice? Prime numbers on dice are, it's this. Sorry, not one is not prime. Okay, 3 and 5, and 2 is also prime. So I'm having 3 prime numbers, 2, 3, 5. That means the probability of getting a prime number on the dice is given by 3 by 6. 1, 2, 3 terms. 3 by total is 6. That is equal to 1 by 2. Similarly, the composite numbers, they are 1, 4, and 6. So these are the composite numbers. Question number 36. When two dice are thrown, the probability of getting a prime number on one dice and a composite number on another one is. So what are the prime numbers on the dice? They are 2, 3, 5. And probability of getting a prime number on the dice is 1 by 1, 2, 3. That means this is 1 by 2. And similar is the, what are the composite numbers? 4 and 6. So probability of getting composite numbers on the dice is 2 by 6. That is equal to 1 by 3. So probability of getting prime on 1, required probability is, that is the probability of getting a prime on the first, and the composite on the second dice is given by 1 by 2 into 1 by 3 multiplied by 2, because 2 dice are thrown. So this is equal to 1 by 3. That means option A is the correct answer. Hope you got that. Let's move to the next question. Question number 37. Let A, B, C be three pairwise independent events of a random experiment such that you have probability of B bar union C bar is equal to 1 by 2, where PA is greater than 0 and PB is equal to 10 and PC is equal to C. Then you have to find out the probability of B bar intersection C bar by A. Okay. So first thing you are given that A, B, C are pairwise independent events. So that means B bar intersection C bar and A are also independent. So probability of B bar C bar upon A, this is equal to this upon probability of event A, which is further equal to probability of B bar union C bar, probability of event A upon this, which is equal to probability of B bar intersection C bar. Now, probability of B bar union C bar, it's 1 by 2, it's given. That means probability of B intersection C whole bar is equal to, this is also equal to 1 by 2 because these two are same. So probability of B intersection C will be 1 minus 1 by 2, that is equal to half. That means probability of B union C. Now, you know this is equal to PB plus probability of event C minus probability of B intersection C. You know this is equal to B, PC is equal to C. We are given this thing in the question and we just calculated this is equal to 1 by 2. So, probability of B bar union C bar is also equal to 1 minus probability of B union C, right? This is equal to 1 minus B minus C and 1 minus B minus C plus 1 by 2 is equal to, this will give you 3 by 2 minus B minus C. All right. So this is the correct answer to our question, 3 by 2 minus B minus C. That means we have option C as the answer. Hope you got that. Next question number 38. Two dice are thrown and the sum of numbers appearing on the dice is observed to be a multiple of 4. If P is the conditional probability that the number 4 has appeared at least once, then 3P plus 2 is equal to. Okay. So first is 2 dice are thrown. That means the total number of outcomes will be, total number of outcomes is 36. Event E denotes sum of numbers is a multiple of 4. And F, it shows that P has appeared only once. 4 has appeared only once. At least once, sorry. At least once. So, what are the possible sample space for E? It is 1, 3, 2, 2, 3, 1, 2, 6, 3, 5, 4, 4, 5, 3, this, and this 36. Sorry, 12. So that's it. That means the probability of event E is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is equal to 9 upon 36. Now let's go for the event F. You at least once 4 appears, at least once. So it will be 1, 4, 2, 4, 3, 4, 4, 4. This, then 4, 4, then 4, 5 also. Right? Yeah, 4, 5, 4, 6, 5, 4, and 6, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means the probability of event F to happen is 11 upon 36. Now, probability of E intersection F is equal to, if you see, both of them, they match only for 4 and 4. This is the only one which is matching. So that means, probability, this is the sample set. So E intersection F, this is only possible for this pair. Now the probability of E upon F, this is obviously 1 upon 36 only, right? Now in the question, it is given that if small p is the conditional probability that number 4 has appeared at least once. So that means small p is the conditional probability that F upon E exists is given by P probability of F intersection E upon probability of E, which is 1 by 36 upon 1 by 9, that is equal to, 1 by 36 upon 9 upon 36, which will be equal to 1 by 9. This is a small p. What we had to find out is 3p plus 2. Okay. So 3p plus 2 is equal to 3 into 1 by 9 plus 2, that is equal to 1 by 3 plus 2, that is equal to 7 upon 3. So we have option C as the answer to this question. Hope you understood. Next is question number 39. In a random experiment of 5 coins, number of heads is defined as random variable. The mean of the random variable is, the mean formula for the random variable in this case is given by n into p. We know n is equal to 5 because 5 coins are given to us. But I need to find out the p. So it is saying in a random experiment throwing 5 coins, the number of heads is defined as a random variable. So what is p in this case? It is probability of getting head in single throw. Of the coin, right? So that means it's of course 1 by 2. Therefore, the required mean, this was n into p. So 5 into 1 by 2, 5 by 2 is the answer. Option D. Hope you got that. Next is question number 40. It says the variance of Poisson variate x is 2. Then p of x greater than equal to 3 is given by. So you are given variance is 2, right? Probability of p of x is equal to k will be given by 2 raised to power k multiply e raised to power minus 2 upon k factorial. Probability x is greater than 3 is 1 minus, that it is 0, plus probability of x is equal to 1 plus probability x is equal to 2. That's it. So this is given by 1 minus e raised to power minus 2 into, so this is equal to 1. And when I put this is equal to x is equal to 1, this will become 2. And when I put this is equal to 2, it will become 2 again, right? So this is equal to 1 upon e raised to power minus 2 into 5, or 1 minus 5 upon e raised to power 2, or e raised to power 2 minus 5 upon e raised to power 2. This is the answer to the question. Let's check. We have option C as the correct answer. Hope you understood. Next is question number 41. It says if the perimeter of the triangle is 20 and 2 of its vertices are this, then the locus of the third vertex is. Let's make the figure first. So this is the given triangle ABC. B point is minus 5 by 0. It's given. This is C, 6, 0. And I've assumed the A coordinates to be HK. Now, in the question, it's given that AB plus BC plus CA is equal to 20. And we know BC. So if you look at BC, this is of course equal to 6 minus 5, that is equal to 11, right? So BC is 11, which gives you AB plus CA is equal to 20 minus 11, that is equal to 9. Okay, let's see now what is AB equal to. This is root of H plus 5 square plus K square. And AC is equal to root of H minus 6 square plus K square. So let's put both of these in this equation. You will get root of H plus 5 square plus K square plus root of H minus 6 square plus K square is equal to 9 square. That is, okay, sorry, it was 9 only, right? So next you can write it as root of H plus 5 square plus K square is equal to 9 minus this H minus 6 square plus K square. Let's do squaring the both sides. You will get, I'll open up the square also. This is H square plus 25 plus 10H plus K square is equal to 81 plus H square plus 36 minus 12H plus K square. So this and, okay, sorry, here was minus. Okay. Okay. So this won't happen. This is supposed to be minus. Now, this can be written as, I have squared both the sides. So it will be, let's open up. This is equal to 2H square plus 10H minus 12H plus 25 plus 36 minus 81 plus K square plus K square is equal to 0, which will give you, okay, one thing I left over here was multiply. Okay. This is something I have missed. I will redo this step, squaring both the sides. This is something wrong. So let's do the squaring on both the sides again. So this is equal to H square plus 10H plus 25 plus K square is equal to 81 plus H square minus 12H plus 36 plus K square minus 2 into 9 into root of H square plus 36 minus 12H plus K square. Okay. So this H square and H square will cancel, K square and K square will cancel. You will have 10H plus 25 minus 81 plus 12H minus 36 is equal to minus 18 root of H square plus 36 minus 12H plus K square. So now this is equal to 22H and 25, 81 and 36. Solving this, you will get minus 92. Yes. You will get minus 92. This is equal to minus 18. Multiply this whole thing. Okay. So while doing these calculations, be a little extra careful because you might end up doing some problems, mistakes, sorry. So this can be written as, I'll divide both the sides by minus 2. So minus 11H, 46 minus 11H is equal to 9 into this. Now let's do squaring the both sides again. So we will do, let's do squaring the both sides again, which will give you 46 square plus 121 H square minus 2 into, that is 92 into 11. So this is 92, 92. This is equal to 1192. 1092. 1012. h is equal to 81 into h square plus 36 minus 12h plus k square. Okay, now let's open up the brackets. You will end up having 121h square minus 81h square minus 1012h. 18 12s are 36 and 18. So this is equal to 216 minus 21 plus, sorry, this is plus 216h plus 46 square plus 81 into 36 minus k square is equal to 0. So solving this whole will give you 40h square minus 40h. Question number 51. If the perimeter of the triangle is 20 and two of its vertices are minus 5, 0 and 6, 0, then the locus of the third vertex is.